So we want to consider the tests for oxidizing or reducing agents. You see, let's begin with oxidizing agents. To test oxidizing agents, you can use strong reducing agents. So we can use hydrogen sulfide, which is a strong reducing agent, or iron 2 chloride, or potassium iodide. And so for hydrogen sulfide, if you add hydrogen sulfide to an oxidizing agent, it quickly oxidizes the sulfur in hydrogen sulfide to sulfur. And that's because the sulfur in the hydrogen sulfide will lose its electron, 2 electrons, to be deposited as sulfur. And the sulfur has a yellow color. So whenever you add oxidizing agents to hydrogen sulfide, you will see a yellow deposit of sulfur. That means to say, whatever you've added that hydrogen sulfide to must have been an oxidizing agent. That's why we have the yellow deposit of sulfur. Again, it's iron 2 chloride. Actually, you see, iron 2 chloride is a green salt because these iron 2 ions are actually green. Now, if you add this to an oxidizing agent, what simply happens is that the iron 2 is quickly oxidized to iron 3, and iron 3 has a brown color. So you will see a brown coloration in your solution. That means to say the oxidizing agent oxidizes iron 2 chloride to iron 3 chloride. So when you add a green solution of iron 2 chloride into an oxidizing agent, it turns brown immediately. And that's because iron 3 has a brown color. Again, it's potassium iodide, actually. If you add potassium iodide to an oxidizing agent, you see a formation of a brown color solution. And that's simply as a result of the formation of iodine, actually. And what has actually happened? The potassium iodide actually loses electron to become iodide. So that's that, to become iodine. So that's that about that. Next is test for reducing agents. You see, 2 important substances are used. Very, very strong. They are strong oxidizing agents, actually. So to test reducing agents, you use oxidizing agents. So KMNO4 and K2CR2O7 is a strong oxidizing agent. This is called potassium tetraoxo manganate 7. And so if you add this to a reducing agent, it decolorises the purple color of KMNO4. And that's because manganese here, manganate 7 here has a purple color. And the moment it's added to a reducing agent, it changes from manganate 7 to manganate 2, which is colorless, actually. Again, it's potassium heptaosodichromate 6. You see, this ion, chromate 6 ion here, has an orange color. The moment you add this substance to a reducing agent, it reduces this from ion chromate 6 to chromate 3, which has a green color, actually. So you see, it changes to green. So that's how you understand that, oh, we have added this thing, must have been a reducing agent. So very, very important. You need to know this also. Okay? So lastly, on redox reaction, we want to see how to balance a redox reaction. And one thing to note here is that you can balance a redox reaction in either acidic medium or basic medium. And the most important thing is that if you are using the acidic medium to balance, or you are balancing a redox reaction in acidic medium, then you are using the hydrogen ion. And if you are balancing a redox reaction in basic medium, you are using the OH, the hydroxide ion. So that's that about that. So these are the steps to balancing redox reaction, and we apply these steps in solving this question. Example 1 says, balance the following equation in acidic medium. So let's start with the very first one now, which is Fe2 plus plus MnO4 minus to give Fe3 plus Mn2 plus. Okay, so the first thing is to write out the half equation. That's step 1. Half equation. The half equation is Fe2 plus that becomes Fe3 plus and the MnO4 minus that became Mn2 plus. Now, step 2 says balance the atom in either acidic or basic medium. Okay? Where the atoms is balanced in the very first one, that's Fe2 plus becoming Fe3 plus. So nothing to balance here. One ion, one ion. Please take note that this 2 plus doesn't mean there are 2 ions here. So that the oxidation state of this ion is plus 2. While the oxidation state of this ion is plus 3. So that's all. But right here, we have 1 manganese here and 4 oxygen. While on this side, we have just 1 manganese. So the oxygen is not balanced. What do? We use, since we say acidic medium, we're using hydrogen ion. So on the part where you have the higher oxygen, the oxygen here is higher than the oxygen here by 4. So because of that, I will add times 2 of hydrogen ion to it. So I'm going to add hydrogen ion. So how many hydrogen ion am I adding? 8 actually. 8 hydrogen ion. And that's because the oxygen here is 4 more than that which is here. In fact, there's no oxygen here, but here we have 4. So on the side you have the higher oxygen. Add hydrogen ion. And the hydrogen ion you will add is times 2 of the number of oxygen you have, or the oxygen difference you have. So since we have 4 here, times that's 8. And here you will have 4 molecules of water. And so now we can tell that 4 oxygen, 8 hydrogen, 4 times 2, 8 hydrogen. So that's balanced. Step 3 says balance the charge. To balance the charge, we use electron to do that. Well, here we have 2 plus, and here we have 3 plus. The part with the higher charge or higher oxidation state, you reduce it by adding electron. So this is actually plus 3, but the electron is minus 1. So plus 3 minus 1 is going to give us plus 2. And here is plus 2. So that's balanced. While for the second one here, which is MnO4 plus 8 hydrogen ion, that gives Mn2 plus 4 molecules of water. If you watch closely here now, this is plus 8. That's because this is plus 1 for hydrogen ion. But times 8, that's plus 8 now. And this is minus 1 here. So plus 8 minus 1 will give me plus 7. Why right here? This is plus 2. Nothing is here. So this is 2 here. Why this plus 7 here? Like I said, the higher one, you use electron to reduce it. So I'm going to add how many electrons here? 5 electrons. Because 1 electron is minus 1. Then times 5. So this is minus 5 altogether now. And when you have plus 7 minus 5, that will give you 2. So this becomes 2 altogether here. You know what I mean is that this is plus 8 here. And this is minus 1 here. Now if you add minus 5 here, this will now make this side plus 2, which is the total charge on this side. So I'm done doing step 3. Now step 4. Step 4 says balance the electron. What it means is that how many electron was used here? That is 1. How many electron was used here? That's 5. You have to balance it. So I have to multiply this first one by 5. So that everything becomes 5, including the electron. That will be 5 Fe2 plus to give 5 Fe3 plus 5 electrons. Since here is already 5 electrons, you don't need to touch it. It remains like that. MnO4 minus plus 8 hydrogen ion plus 5 electron to give Mn2 plus 4 molecules of water, and that's all. Now lastly, now step 5 is to add up. So what I quickly do is that add up the left hand sides together, this and this. That will be 5 Fe2 plus MnO4 minus plus 8 hydrogen ion plus 5 electrons to give, now I will add up the right hand side together too. That's 5 Fe3 plus Mn2 plus 4 molecules of water before writing the 5 electron. Now note something here now. We have 5 electron here, we have 5 electron here. If you bring this 5 to this side, it becomes minus 5. So they will cancel out eventually, actually. Now, nothing else is here that we can also find here. So that's all. So we now write 5 Fe2 plus MnO4 minus plus 8 hydrogen ion to give 5 Fe3 plus Mn2 plus 4 molecules of water. That's all. Now you can tell that it is balanced. And how do you know that? Check 5 ion here, 5 ion here, 1 manganese here, 1 manganese here, 4 oxygen here, 4 oxygen here, 8 hydrogen, 8 hydrogen. Atoms are balanced. Now check the charge. This is plus 2 but times 5. This is 10 here, plus 10 here, and this is minus 1 here, and this plus 8 here. If you add up all this, you have 17 at the total charge of the left hand side. On the right hand side, what do you have? This is 3 times 5. That's plus 15. 15. And then here, this plus 2. If you add up everything together, it becomes 17 likewise. So the charge is also balanced aside from the atom. So that's that about this. Let's take the second one. Number 2. We have Cr2O7 2 minus plus SO2 to give Cr3 plus SO4 2 minus. Now again, like the first step, write out the half cell equation. And so the half cell equation, that's step 1 now. Cr2O7 2 minus to become Cr3 plus, and SO2 to become SO4 2 minus. That's step 1. Step 2. That is balance the atom. Right here, we have 2 chromium, but 1 chromium. That's not balanced. So we'll do that firstly. I've balanced the chromium now. The next one is the oxygen. We know we balance the oxygen with hydrogen ion since we are told that this is acidic medium. So how many oxygen do I have here? We have 7. So we have to add 14 hydrogen ion. And right here we have 7 molecules of water. Now the oxygen is balanced because 7 oxygen here, 7 oxygen here, and 14 hydrogen here, 14 hydrogen here. Now for the second one, we have SO2 and we have SO4 2 minus. Now the oxygen here is more than the oxygen here by how many? By 2. Where you have the higher oxygen, that's where you add the hydrogen ion. So I'm going to say plus hydrogen ion. How many hydrogen am I going to add? Some think that because you have 4 oxygen here, add 8 hydrogen. No, please, not that. The oxygen here is bigger than that in the left hand side by 2. So you add 4 hydrogen ion. And right here you have 2 molecules of water. Then let's move to step 3, step 4, and step 5. So for the next step, which is step 3, which says balance the charge. Looking at this now, Cr2O7 2 minus plus 14 hydrogen ion, which gives Cr3 plus 7 molecules of water. Now I'm going to ask myself, already this is minus 2 and this is plus 14. And that will be plus 12. And here is just plus 6 because this is plus 3 times 2. And so you understand that I have to bring down this 12 down to become 6. How many electrons do I need to do that? Plus 6 electrons. So that's that about this. Now for the second one, let's clean all this number to avoid so many digits. Now here we have SO2 plus 2 molecules of water. And here we have SO4, 2 minus, plus 4 hydrogen ion. Now if you watch closely here, you see that you have minus 2 here and plus 4 here. Eventually everything here becomes plus 2. And everything here is 0 because no charge here, no charge here, so 0. You have to bring that inside of plus 2 down to become 0. You need just 2 electrons to do that. Having done that now, the next one is to balance the electron, which is step 4. Now to balance the electron, how many electrons was used here? That's 6. How many electrons was used here? That's 3. So I have to multiply everything, that's 2, sorry. So I multiply everything here by 3. So the first one remains the same. The second one I multiply by 3. That's 3 SO2 plus 6 molecules of water to give 3 SO4 2 minus plus 12 hydrogen ion now, then plus 6 electron. Now the electrons are the same, we balanced it. Now step 5, which is the last step, add up. So I'm going to add this to this, and that will be Cr2O7 2 minus plus 14 hydrogen ion plus 3 SO2 plus 6 molecules of water plus 6 electron to give 2 Cr3 plus 3 SO4 2 minus plus 12 hydrogen ion plus 7 molecules of water plus 6 electrons. So right here, 6 electrons cancel out 6 electrons. First of all, that's settled. Now we have 6 molecules of water here. You have 6 molecules of water here. Bring the lower one, 6 to this side, become minus 6. If you have 7 water minus 6 water, you get 1. This will cancel out, remaining just 1 molecule of water. Like I said, okay, this is 6, this is 7. Minus 6 molecules of water from here, minus 6 from this. Now we cancel out this, and this will remain just 1. Another way to say it. Here you have 12 hydrogen ion, you have 14 hydrogen ion. Minus 12 from here, you get it's gone. Minus 12 from here, it remains just 2. So that's the common elements or atoms or ions. So at the end of the day, or compounds. So at the end of the day, we now have Cr2O7 2 minus, then plus 3 SO2, then plus 2 hydrogen ion. That's correct. To give 2 chromium 3 ion plus 3 SO4 2 minus, then plus 1 molecule of water. And you can check and confirm if it is balanced. How do you know that? The atom, 2 chromium, oxygen, 7 here, plus 6, that's 13. Here, 12 plus 1, that's 13. Hydrogen, 2, sulfur 3. So the atoms are balanced. Then the ions, this minus 2 and this plus 2, make a total of 0. Well, here this plus 6 and this minus 6, make a total of 0. So it is balanced here. So that's that in acidic medium. We're going to take one example for basic medium. Example 2, and this is in the basic medium. So we have to balance this in the basic medium. So the first step, as usual, just like in acidic medium, the same similar steps. Write out the half cell equation, and we've just done that. Now step 2. Balance the atoms. So Cr3 plus 1 chromium here, and right here 1 chromium here, but 4 oxygen here, and here no oxygen here. So I'm going to add OH because this is basic medium. I'm going to add, to the side we have the fewer oxygen. That's where you add your OH. Unlike the acidic medium, the side you have the higher oxygen, so you add your H plus. But yeah, the side you have the lesser oxygen, so you add your OH. Then here plus 4 molecules of water. And then next is BrO minus and Br here. So here I'm going to add, but here I have the fewer oxygen. So I'm going to add 2 molecules of water. Oh, sorry, yes, 2 molecules of water. And here I'm going to add, not 2 molecules of water, sorry, 2 OH minus, because we have the few oxygen here. And I'm going to add 1 molecule of water here. So that's settled now. Now step 3, I've balanced the atom here. So step 3, balance the charge. We have Cr3 plus 8 OH minus to give us CrO4 2 minus plus 4 molecules of water. Now, if you watch here carefully, you have minus 8, because this is minus 1 times 8, that's minus 8 plus 3, that's minus 5. And right here, you have just minus 2. So this is higher. Reduce the higher one. So here we have 3 electrons. So if we reduce that now, while for the second one, we have BrO minus plus water. That gives us Br minus plus 2OH minus. Right here, this is minus 3 here, and this is just minus 1. So you have to bring 1 minus 1 to minus 3. Reduce it to minus 3 by adding 3 electrons. Sorry, 2 electrons. And so the charge is balanced. Now, step 4, balance the electron. Here, 3 electrons is used. Here, 2 electrons is used. How do we balance it? Multiplying this by 2 and multiplying this by 3. It becomes 66 electrons. That's the easiest way to balance it. Now, that will be, if you multiply here by 2, that will give me 2 chromium plus 16 OH to give times 2 CrO4 2 minus, then plus 4 molecules of water, 8 now, then plus 6 electrons. And right here, you're going to say multiply by 3. This is 3 BrO minus plus 3 molecules of water, then plus 6 electrons to give 3 Br minus plus 6 molecules of water. So we are done. Multiplying by 2 and 3. Now the last step is to add up. That's step 5. Before eliminating common terms. Okay? Sorry, this is OH, 6 OH, not, please, my pardon, okay? And then plus 6 electron. Okay, the 6 electron cancel out the 6 electron. Here we have 3 molecules of water, we have 6. Minus 3 from here, minus 3 from here. This will be 0, and this will be 5. And here we have OH. Minus 6 OH from here, this is gone. Minus 6 OH from here, this is 10. Remaining. So we now have final answer 2 chromium 3 plus 3 BrO minus plus 10 hydroxide ion to give 2 CrO4 2 minus plus 3 Br minus plus 5 molecules of water, and that's all. And we can tell if it's balanced or not. Let's see now. This plus 6 and this minus 3. 6 minus 3 and then minus 10. This is going to be minus 7 not together. And this is minus 4 and minus 3. That's minus 7. 2 chromium, or let's use this 2 chromium, 2 chromium. Oxygen 10 3, that's 13. Oxygen 8 and 5, that's 13. Bromine 3 bromine, 3 bromine. Hydrogen 10 hydrogen, 10 hydrogen. So it's balanced. So this that